Okay, everyone. So I wrote quiz 3 and I'm just going to look over it, make sure everything is okay with it, kind of like rearrange some questions, and I will post it today, probably by 5 p.m. the latest. And I encourage you to go to your tutoring sessions because your tutor helps you with the problems and kind of like solve you similar problems to the exam. So I highly encourage you to go to that. And I also hold some extra office hours. As I said, I still have my office hours Monday, Wednesday, Friday, 12:30 to 1:30, basically right after the class. But I added some extras, so I give you the opportunity to ask me questions. And I had some students coming to me, and then we reviewed naming ionic compounds, molecular compounds, and acids. And I realized that there are like so much confusion about those, and can be confusing. But I think in that video we went through them, and I also said in that video what I expect you to know, what I give you in the exam. That basically, to summarize that, if we look at chapter 5, and I'm going to show the book for a moment here. Okay, so first of all, something that I expect you to know is that when you go, guess I do zoom out. Okay, when you read your book, there are like some important informations, like when you read like through the pictures, and kind of like when you learn the concepts, and I may ask you, in the quiz, and I already asked you, so I'm just telling you that, you can refer to these concepts, in your book, and then kind of like get an understanding if you want to answer the questions. And also, one thing that I mentioned in the review session that I'm going to mention here too. So for table 5.3, which is like polyatomic ions, I expect you to at least go through them, write them, or however you learn things, one time or two times, so you have familiarity with them. So when I tell you carbonate, you know that it has, carbon and oxygen, or like, when I say like chlorate, you know that, it has like chlorine, oxygen, but I don't expect you to memorize all of them as such. I'll give you this table in the exam. But I expect you to know, kind of like, as I said, nitrate, what does it have? So kind of like even like writing them 2 or 3 times, so you have some familiarity with it. So if someone asks you, potassium nitrate, you have an understanding what nitrate is, but in the sense of like, knowing everything, I'll give you the table to make your life easier, and you can focus on other materials in the book. So any question about this? Okay, and also I went through some example problems in the other 2 videos that I posted, that I encourage you to, listen to, or if you don't have time, at least, fast forward, solve the problems yourself. So any question about the quiz, or like, anything that we talked about before? Okay, so I'm going to start with chapter 7, which is chemical reactions. And if you remember, your book gave you 3 examples of like your daily life, things that, we encounter. And one of them is like grade school volcanoes. So you don't encounter that every day, but probably you did such an experiment, when you were like much younger, that you have like a clay volcano, and then you add vinegar, and then you add baking soda to it, and then you see eruption, right? And I also want to show you the YouTube recording. So basically we watched the video of the reaction of baking soda with vinegar. And then the other example that your book gives is that, when you drive a car, you have like a hydrocarbon that we're going to talk about them more. Basically, your gas consists of, octane, for instance, or like different hydrocarbons, or even if you your car functions with diesel, it's the same thing. Basically, the rationale that it burns and then it produces lots of energy, lots of heat that makes the cylinder in your car moves, and then you see the exhaust going out of your car. So it makes your car function. So this is another type of reaction. Or the other thing is that, you probably noticed, if you wash things often yourself, that if you use soap instead of laundry detergent, you may not have, basically laundry detergent is more effective than soap. And then if you use soap, you see a gray, slimy material forming, and that is because the water can be like having like minerals that makes it hard. So basically you can have magnesium or calcium, and those ones, laundry detergent has materials in it that prevents formation of unnecessary, slimy gray materials. So basically, these are all examples of reactions that we encounter, in our daily lives. Or, if you have like spoons, some of the spoons, are like more metallic, and then if you just soak them for so long and then you don't wash them, with the, as time passes, you see like, brownish, particles is forming in the spoon, or like, by the edges, so those are basically iron oxide. So there are like several examples of different reactions that we see in our daily life. So to define that, and again, the same thing that I said with chapter 5, these are like the first few pages of chapter 7 has so many information that I'm going to ask you in the exam. I think, first of all, it helps you understand the materials well, and it's kind of like can increase your grade, because it's just like easy questions that as long as you know the materials, you can kind of like basically increase your points. So, and I go through almost all of it here. So chemical reaction is transformation of one or more substances to another or different substances. So basically, the transformation of, let me just go back to HTML. Okay, the transformation of one or more substances into different substances. And then depending on what type of reaction we have, that I'm going to walk through you in this chapter and then explain them, we have like different types of reactions. And let me just so we talked about the grade school volcanoes. So basically, in order to write a chemical reaction, we write a chemical equation. And here I'm just going to, at the kind of like end of the session, I'm going to talk about chemical equations more. But in general, in this example that I gave here about acetic acid and baking soda, the experiment that we just saw, we have like acetic acid, reacting with sodium bicarbonate, which is basically baking soda. And then acetic acid is basically our vinegar. and then they produce water, carbon dioxide, and then sodium acetate. So the reason that I'm writing these now is for the sake of your exam and then your quiz. So because I just want to go through quickly naming acids and also ionic compounds. So this is the main reason that I'm writing this here. Otherwise, your book just like gives explanation to encourage you to write and learn chemical reactions and chemical equations. So basically, can anyone tell me what is the chemical formula for acetic acid? So I'm going to give you the table that has acetate. So if you know that this is acetate, so again, I expect you to go through the table. When I say acetate, you know that, okay, it has carbon, hydrogen, oxygen. So have some familiarity with it, but I'm going to give you, the formula for acetate. So if this is acetate, based on that, can you write acetic acid? Anyone?
No.
So why can't you write it?
I don't really have a reason. It just doesn't make sense.
What do you mean it doesn't make sense? So, imagine I told you write the chemical formula of acetic acid. So how would you write that? So what is an acid? Yes, exactly. And then if you write hydrogen and then naming, acids, you remember that we had a rule that if our, polyatomic ion, if it ends with 8, we add we have the base name of the, our acetate. Basically, we take that and then add ic plus acid. So basically, we can write this as this. Remember? Naming acids. Do you remember this? So you have base name of oxyanion plus, here in this case, because it ends, you have acetate, basically here. Where is it? You have acetate, if you can see it. It ends with ATE, And then here you have base name of oxyanion plus ic acid. So it's nitrous acid, nitric acid, sulfuric acid, and then acetic acid. So this is something that I'm going to ask you in the exam. So if you have any problems with this, I encourage you go look at the lecture that I posted, and also, just come ask me, So this is the reason that I just, I'm writing these equations now rather than later for the sake of your exam. So this would be acetic acid or sodium bicarbonate. The same thing, You remember that for naming this, when you have polyions, you have sodium, you just write sodium as such, and then bicarbonate. Or the same thing for sodium acetate. You write sodium and then you write acetate. And then the charge of both is -1 + 1, so you don't write them. So if you don't know how to name these, I encourage you to just like whether watch the video or ask me to how to name this. Any question about this?
I have a question.
Yes.
So the C2H3O2, that was acetate, and so then did it turn into acetate acid when you added the hydrogen? Is that what you're saying?
Acetic acid, yes.
Okay.
So when the name of your polyanion, it ends with ATE, like acetate, you change that, you write the base name, but for the acid, change it to ic. But if it ends to, but if ends with ITE, you change that to OUS, like, like sulfurous acid or like nitrous acid. Anyway, so as we said, chemical reaction is transformation of one or more substances to different substances. And then one type of reactions based on what I just mentioned here, like have like vinegar, you have like baking soda, and then they form like those bubbles of carbon dioxide that we just watched in the video. So we call these reactions gas evolution reaction. That are basically reactions that occur in liquid and form gas, like the baking soda and vinegar. So these are reactions that occur in liquids and form a gas. So this is one type of reactions, gas evolution reactions. So the other type of reaction is kind of like, if you have like piece of wood and then, if you go camping or, outside and then you just want to, bake something or like cook something and then you just like have some wood and then you just like put, some gas in them or just like, they make some fire. So basically kind of like burning things. In general, we call those combustion reactions. Or the example in, automobile that you have like octane, it reacts with oxygen and it produces, carbon dioxide, water, and lots of heat. So in combustion, a substance reacts with oxygen, emitting heat and forming one or more oxygen containing compound. So you remember like, the gas in your car or like, as I said, in the stove that, you're like cooking things and then methane reacts with oxygen and then you can see, the light, you can, feel the heat when you're burning something up, And then combustion reactions are form of oxidation reduction reactions, which I'm going to write, through oxidation reduction reactions, electrons are transferring between compounds. So combustion reactions are a subcategory of oxidation reduction reactions in which electrons are transferred from one substance to another. So far we learned about gas evolution reactions and combustion reactions and oxidation reduction reactions, which combustion reactions are some kind of oxidation, or they are like subcategory of oxidation reduction reactions, because in them also electrons are being transferred. Any question about any of this? So we so far learned about, an example of, so if I ask you, give me an example of gas evolution reactions, what would you say? Anyone? So that is a good point. Actually, I was going to talk about this in a bit. So boiling water is tricky and it's kind of like deceiving, because you see water, you see bubbles, and then you may think that is a chemical reaction, but that is a physical, reaction. It's kind of like transformation of water from liquid state to gas state. So we said, if we go to the definition of, if I can just scroll down, if we go to the definition of chemical reaction, is the transformation of one or more substances into different substances. So we have water in liquid form and in gas form. Is it different substance? So what is let me ask you this, what is the chemical formula of water in liquid form? Yes, so what is it in the gas form? Exactly, so it's the same substance. So that is not a chemical reaction, and this is, thanks for bringing it up. I was going to talk about this, later in the course, in the lecture. So not necessarily, if you see evidence or things, not necessarily is the chemical reaction. You should have a different substance. So if the water was, transforming to just hydrogen, or oxygen, and then this is the thing, that if you only have hydrogen, you just can't have hydrogen and oxygen, the constituent element. We need other substances to react with oxygen in order to get, more or different substances. So any question about this? So if I ask you to give me an example of gas evolution reaction, it should be two substances react, or one substance, react in liquid and produces gas. So one example can be just baking soda and vinegar that I just talked about. If I ask you to give me an example of combustion, you can just give me several examples. If you just burn anything and it produces, basically burning anything, almost is kind of combustion. Or one example can be your gas in the car burning and then producing carbon dioxide and water, or this stove, and so on and so forth. And then oxidation reduction reaction, it can be the rust that forms, in the edge of your car, or the dulling paint, or as I said, if you have nails and then you just put them in water for a few days, when you come back they are all has an orange color in them, or brownish depending on the texture. So all of these are examples of these reactions that I talked about so far. And then the other example that your book gives is laundry detergents. And it gives these specific examples for different types of reactions that it's talking about. So as I said, depending on what, if you have just like clear water and it doesn't have any ions, basically calcium and magnesium, you can just simply, wash your clothes with soap too. It won't be an issue. But if your water would have, these anions, so basically, cations, these ions, I meant to say. So if you have like Ca2 plus or like Mg2 plus, in water, we call that hard water. And then these ions interfere with the cleaning of the your clothes if you use just like hand soap or like ordinary soap. And then they form, as I mentioned, a gray slimy substance that we call that curd or soap scum. So basically I'm just going to write this. These ions interfere with the cleaning action of soap by reacting with it to form a gray slimy substance called curd or soap scum. And laundry detergents, they contain substances that they react with these ions, basically Ca. So this is Ca2 plus. So laundry detergents, content in comparison with soap, they have, material substances in them that they react with these two ions and make them precipitate. So if you wash your clothes with laundry detergent, if you even have like hard water, it won't cause, the soap scum or curd. And then I just write here that laundry detergents contain substances such as sodium carbonate. And again, you should be able to write this, this ionic compound, and then the ion separately, and then the ionic compound in the exam. So it would be like Na for sodium, and then carbonate is like CO3 2 minus, and then if you want to write NaCO3, if you want to write the compound, ionic compound, this has like -2 charge. This has like, it has like Na plus 1. So in order to be, neutral, you should have like 2 of this. So this is sodium carbonate. So anyway, so this is kind of like a side note. But laundry detergents contain sodium carbonate that reacts with calcium and magnesium and make them precipitate. So contain sodium carbonate that remove calcium and magnesium ions from the water. So basically, if you if you have like sodium carbonate, this one, dissolves in water. So let me just. Dissolves in water, and you will have sodium and carbonate. And then this carbonate reacts with your heavy metals, such as like magnesium or calcium that we mentioned, and then forms a solid precipitate. So basically, you have like CO3 2 minus plus Mg 2 minus, and it gives you like MgCO3. And I teach you, as we go, how to write chemical equations. But this is kind of just like for the sake of demonstration that what happens. So to recap, you have like, laundry detergent that has like sodium carbonate in it. And then that sodium carbonate in water, dissociates or like separates into its constituent ions, which is like sodium and carbonate. And that carbonate goes react with the ions that you have that cause the water being hard with those ions, and then you can have like magnesium carbonate, and then that one precipitates. So that these ones, when you use laundry detergent, you don't see the scum or like that slimy gray substance that we talked about. Any question about this? Is it clear what happens? So we call this type of reaction precipitation reaction. And those are reactions that form solid substances in water. And these types of reactions also are being used to separate, toxic metals in water. And also industrial wastes. Any question about this? Or any of types of reactions that we talked about so far? So this was an example of precipitation reaction. So the book wants to give you understanding of different types of reactions and, kind of like giving you tangible examples in daily life. And, when I explain things further, I come back to these reactions and then teach you how to properly write these chemical equations, balance them, and so on and so forth. But right now, just like, I expect you to know that we have like different types of reactions, like, oxidation, reduction, precipitation, combustion, gas eruption. And then we gave examples of those. So is it clear? Yeah. Okay. So chemical reactions, as we mentioned, they are all around us. They are like even in our body. They are like in us, and then we have like different reactions going on. And, in our experiences and then in daily life and even in products that we buy, in many of them, almost, we are surrounded by chemical reactions. And chemical reactions can be simple, such as like formation of water, that you have like hydrogen plus oxygen gives you water. And they can be really complex, such as synthesis of proteins, that they, there are like several compounds and several components, several compounds that they, should react with each other to form a protein. So basically, I just write chemical reactions can be simple or complex. And then if I want, you to give me examples, this one can be like formation of water, that hydrogen and oxygen form water, and they can be complex, such as synthesis of protein molecule from thousands of simpler molecules. Chemical reactions also can be noticeable. So if we see like a building on fire, you see that, oh, okay, there is a, really evident, evidence that a chemical reaction is happening, right? Or like if you see the exhaust of the car, you are seeing that, it's tangible. Or like the eruption experiment that we talked about baking soda and vinegar. Those are like the things that you can just like see. But there are also chemical reactions that, are not, noticeable, or you cannot see them, with, naked eye. So there are like, if I want to write this, chemical reactions can be not noticeable, like acid added in swimming pool to adjust water's acidity level. So you don't see any, you don't see anything noticeable that a chemical reaction is occurring. But, if you do that based on the results and based on the chemical formulas, you know that it's happening. Or it can be noticeable, like combustion reaction. So something that you should, remember is that chemical reactions produce changes in the arrangements of the molecules and atoms and often these changes, you see the macroscopic change and then you can see them, but not necessarily, you cannot see. As we talked about, they can be noticeable or like not noticeable. Now, I'm going to talk about evidence of a chemical reaction. So there are like several ways that, I told you there are like some chemical reactions that are like noticeable and some that are not noticeable. So for the ones that are noticeable and you can see change, there are like different things that can tell you that the chemical reaction is happening. So one of them is like color changes. For instance, if you put your clothes that have like, specific type of colors in them, like bright colors, and then you put them in front of the sun for long periods of time, when you come back, you see that this color is fading. So you realize that, oh, the color has changed, so a chemical reaction has occurred. Or like, you see that those spoons that, you feed like baby spoons basically that you feed babies with. So if they get like hot, and then with time, when with temperature, their color changes. And your book has like really good examples and have pictures. I encourage you to go study those. So that is kind of like a sign of a chemical reaction. So color change. The other one is formation of solid. The other one is formation of a gas. So for formation of solid, we gave the examples of laundry detergent, right? That, it's not like it should be conducted in more experimental setting, in the sense that you can see the precipitates, But there are like certain experiments in the laboratory that you add substances to each other, and then you see like the solid, the precipitate forming, But the laundry detergent, it also has similar effect if you use like hard water and then the things that we just talked about. Formation of a gas, an example can be like baking soda and vinegar. You see like carbon dioxide, or like if you don't know it's carbon dioxide, probably you don't know exactly, but you see bubbles that tells you that, a chemical reaction has occurred. And remember, like the example of boiling that we said, you should see a different chemical, so different molecule. So water transformation would be like physical reaction, it won't be chemical. The other one is like heat emission, or I'm going to write them separately, light emission. That most of the time when you see heat, you also see light, kind of like combustion reactions. When you burn something, you see, or in your stove, you see light. Depending on what type of stove you have, but the ones like that, methane stoves, you most of the time see, or just as I said, if you burn something, you see light, you also feel heat. So light emission, heat emission, or you can have heat absorption. That if you have like an ice pack, and then in certain types of those, there are like two chemicals separated, and then when you kind of like break those, you see that you see it becomes so cold because they are absorbing the heat. And kind of to understand these better, I'm going to use your book to show this. So here, in this section, we have like evidence of a chemical reaction, and then you can have like precipitation, that you see solid formation, or, like gas formation, that, you see like bubbles forming. And then this is like the ice pack that I told you, that you have like, two sections that are like separated. When you break those, you feel the cold because they absorb the heat. And then this is like the baby spoon that I was saying. You see that the color changes, so you realize that a chemical reaction had occurred. And then here is also a summary of the evidence of a chemical reaction. And I'm talking about like page 208 of the book for the recording. So we have like a color change, or we have like a precipitation. You see like the solid forming, or like gas forming, or like you see light, or you see emission or absorption of the heat. So this was an example of the absorption of the heat. So any question about, yes?
What chemical
yes, it can create liquid. So when you have like hydrogen in the gas form, and then the hydrogen and oxygen in the gas form, they react with each other, we see water. So it can be, we have like different types of chemical reactions, and when we progress in the chapter, we talk about them. So, if any more questions? Okay, if I can just manage my pen. I'm going to talk about the chemical equation that I know that I told you I'm going to talk about chemical equation, and you're dying to see what is chemical equation. So basically, chemical equation is a way that we can write chemical reactions. So we can say chemical equations is a way to represent chemical reactions. For instance, in your stove that I talked about, that we have like methane and oxygen, and then it produces carbon dioxide and water. So instead of me telling you that, okay, this is soap, this is, laundry detergent, and then we add them, to the hard water, and then this happened. Instead of boring you with like stories, I can just write a chemical equation, and it tells you what happens. And in the left-hand side of the equation, we write the materials that are reacting with each other, and then we call them reactants. And in the right-hand side, we write the things that are produced in the chemical reaction, and we call them products. And most of the time, so far we learned that we write, reactants on the left, and then we have an arrow, and then we write the products on the right. And most of the time, because we want to know, as your friend mentioned, we want to know what is the state of the substances that we have. So we add their state as well. So we write like CH4 in gas form plus oxygen in gas form gives CO2 in gas form plus H2O in gas form. And then your table 7.1 gives the abbreviation of the states of the reactants and products in chemical reactions. So if you have you can have gas, liquid, solid, or aqueous. It means that there are water solution. And we are going to talk about solutions later in the chapter. So you write gas, you write liquid, solid, and aqueous. And you write these in parentheses in front of your compounds. Any question about any of these? Yes?
What is the last one below solid?
Below is aqueous. And then you write it AQ in parentheses. So I encourage you, if you have any difficulties with naming compounds or chapter 5 and 6, whether go to tutoring session or email me, I happily explain it to you, before you see them in the quiz and in the exam.